think they fixed, or actually they say they fixed what caused the Zoom to freeze. We'll find out. I don't know, but we'll just hang in there and do. Before we go, well, actually, I'll wait a few more minutes for people to show up before I start talking. So let's do a real quickie review. We have two ways of finding slope. Okay, the first way is with the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or the second way, if you have an equation like ax plus or minus by equals c. If you got some crazy equation that looks like that, and we talked about this, I'm just doing it using different vocabulary, slightly different notation. You need to get used to that kind of stuff. If you can take this equation and solve for y, if you can take that equation, in other words, move x to the other side, get y alone, you get this. This equation is known as slope-intercept. It's called actually slope-intercept form. And when you read that, m is the slope and 0, comma b is the ordered pair, whatever that number is the y-intercept. Now, that's a real quickie review from last week. So what I want to do here is for each of these real quick, I want you to find the slope. Just, okay, I want to write it. I want you to find the slope. Problem A is going to be the point 17, comma negative 6. And that's going to be the point 20, comma negative 8. Problem B, point R is going to be 15, comma negative 3. And point T is going to be negative 7, comma negative 3. Problem C is going to be 2x minus 3y equals 4. Problem D is going to be 4 plus 3y equals negative 3. So, given a quick review, we have those two formulas, okay, that define or help us calculate slope in some way, okay. I want you to use those or your knowledge to find the slope for each one of these problems, given whatever information I have up there. Okay, so let's pause while people log in. Okay. All right, anybody want to shout out an answer for problem A? What'd you get? Anybody?
Negative 2 over 3.
Okay. Anybody get a different answer? All right, that's what I got in my head. I mean, I was doing this problem in my head. So I'll put a check there. Before I erase this, I'll ask if anybody wants me to go over this, but yeah. Okay, my M's are kind of spazzo. Hey, how about letter B, problem B? Anybody get an answer for the slope for that one?
0 over negative 22.
Okay, M, whoops, problem number B, M equals 0 over negative 22 or just 0, whichever. Yeah. Again, that's what I got. Okay. What about C? Ain't somebody different? Anybody? Anybody different? Come on.
I'm going to say C is negative 4/3. M equals negative 4/3.
Yeah, yeah. Okay. M equals -4/3. Again, I'm doing that one in my head and I didn't come up with that. Let me think about it. Anybody get anything different? Okay, I still keep getting a different answer in my head. Okay, let's try D.
C is y equals 2x 2/3x minus 4/3.
Well, that's the equation. Okay, so for C,
Hey, get out of here. Go.
wait, who are you talking to? I can't get out of here.
Oh, sorry.
You talking to your dog or your kid or your wife? Never mind. I don't want to know. Nothing. Okay. So we take 2x away from both sides. We get -3y equals -2x plus 4. Divide everybody by -3. Clean it up. Y equals +2/3 x plus 4/3. Remember, the slope is the number in front of the x. Okay, the 4/3 would be the y-intercept. So I'm going to come back and say it's 2/3 for that one. Okay, anybody different for D? I'm sorry. Speaking of dyslexic. Anybody? Oh, I tricked you. Nobody wants to take a chance? Okay. I'm going to erase these problems so I can do D here in this space. Does anybody have any questions about my answers for A or B or C? Everybody's happy with those. You can use your formula for finding slope for this one. By the way, on letter B, what happens? What would your answer be if the 0 was in the denominator?
DNE.
DNE does not exist, no slope, that kind of stuff. Yeah, whatever mom says, okay?
Professor,
There.
I have a question.
Sure,
In number C,
yeah.
in the answer, you have y equal 2/3 x
Mhm.
plus 4/3. It's not, the third is not a negative sign and it's supposed to be a negative. The denominator is supposed to be negative.
You're right. Yeah, I was intent, you're 100% right. Okay. I screwed up. Okay. I was concentrating more on the slope. The denominator was -3, negative divided by negative is positive. So I was right in terms of my slope. I was wrong in terms of my equation. I should have divided by -3. That should be -4/3 there. Good catch. Thank you very much.
Thank
Did
you.
everybody pick up on that? You might want to go back and fix your notes. Okay, good catch. Thank you. All right, let's go back and look at D. D has 4 plus 3y equals -3. Okay, it's not a misprint. So we're going to get the 4 over here. So we're going to get -3y equals -7. Take away 4 from both sides. Okay, take away 4, take away 4. Divide by -3. Okay, and we get y equals 7/3. Now, there's no x, so this is a trick question. There's no x, so this is a trick question. Okay, now this right here is the equation. of the line, but I didn't want the equation of the line. I wanted the slope. There's two ways we can do this. Two ways we can attack it. I'll show you the short way. You may not like it, and then I'll show you a slightly different way. If you look at this, you can cheat in 0 times x. What gives me the right to do that? How come I could just go put in 0 times x? Remember, by the way, my maturity level is somewhere around middle school. That's why I keep making these funny noises. What gives me the right to throw in 0x just in the middle of a problem?
Because technically x doesn't exist in this equation.
Yeah, x is 0, it doesn't exist. So 0 times x isn't there. But when I put that 0 there, now I've made my equation look like that equation. I've kind of made it look like the form of y equals mx plus b. So because I was able to cheat it in, I can say, look, the slope for this one is 0. That's one way to do it. Now that's kind of tricky. Okay, not everybody is really happy or really can grab onto just throw in something because we want to throw it in there. Okay, and you can't just put it in all the time and all kinds of stuff. But that's one way. Okay, the alternate way, and this is also a little awkward, is to look at this line. Hang on a minute. If we look at this as y equals 7/3, okay, there's no x. So the way I taught this the other day is literally this means y is stuck at 7/3. Okay, y is stuck at 7/3. You can't change it. And all the other tables and everything with x and y, they always change, whatever. But y is stuck at 7/3, and x can be anything. It can be 0, it can be -2, it can be 9, it can be whatever you want it to be. So if you plot those points, 0, 7/3, well, what is 7/3? That's 2 1/3, roughly. Okay. When x is 0, y is 2 1/3. When x is -2, y is 2 1/3. When x is 9, here's -2, here's 9, y is 2 1/3. So we can look at this, it's a horizontal line. It's a horizontal line, okay? So all horizontal lines have a slope of 0. That's guaranteed. Every horizontal line in the world has a slope of 0. Okay, so that's two different ways we could have found the slope on that equation. One is by trick way, by slipping in the missing x, 0x, okay, and just figuring out the slope of 0. Another way was to build a table, graph it, and get a horizontal line. Horizontal lines always have a slope of 0. There's a third way, and that would be to take these points right here and use the formula y sub 2 minus y sub 1, x sub 2 minus x sub 1, and you're still going to get 0 out of something. So there's a whole bunch of ways to do this particular problem. Okay, before I move on to a different review, this is all, in my mind, review from last week. Is this okay with everybody?
I have a note.
Okay, go ahead.
So it's going back all the way to the beginning of D.
Oh,
the-
yeah, okay.
3y, you made it -3y.
Oh, God.
Yeah.
Okay, see, now I'm ticked at you. And I'm pissed at you. Why didn't you yell at me then? See, it's your fault, not mine.
Sorry.
Isn't that what everybody says? It's your fault, not mine. Damn it. Why didn't you yell at me? Okay, well, what
I don't
changed?
want to interrupt.
Oh, okay. By now you should know better than you can interrupt me. I don't get too upset. Damn it, damn it, damn it, damn it. This is going to be a bad night, isn't it? This is going to be a bad night. Does that change my slope? No. Does it change my graph? Yeah, it'll be down here in horizontal, but it'll still be the same thing. Dang, this is all being recorded. Okay, and we have a new person watching me thinking, oh my God, he's an idiot. Okay.
Oh, the mistakes I've
Yeah.
made. That's not
Oh, oh yeah.
so easy to make those little mistakes.
Yeah, but see, I'm supposed to be teaching and I'm supposed to be, you know, I'm supposed to know all this
None of us
crap.
are immune.
Yeah, that's for sure. Okay, thank you for catching that. Okay, and don't wait. Okay, every time when you wait and make me go back and redo it again, then I look even dumber. Okay, or maybe that's what you were doing. You were waiting for me to really dig my hole deep. Well, okay.
I'll yell next time.
Okay. Thank you. I'd appreciate it. Okay. One thing I want to do before I go on to a different review topic is I want to talk about, I'll call them the types of slope. Okay. We can have positive, if we could spell it right, we could have positive slope like y equals 2/3 x plus 1 or something like that. Well, that's going to be a line that goes something like this. All positive slopes, the m is positive 2/3. All positive slopes are slanted in this direction. Okay, always. Well, you could have negative slopes. Okay, that would be something like y equals -5/2 x minus 3, or let's go plus 3, just to be weird. Okay, and here's plus 3. It'll look something like this. This is 3. This is 1. Okay. I'm not really interested in the y-intercept now. I'm interested more in the concept of the slope. The slope is -5/2. Okay, so this is a negative slope. All negative slopes look that way. They're slanted down. Okay, now they may not be this steep, but they're slanted in this way. They go from high to low, left to right. Okay, positive slopes this way. We can have zero slopes. Okay, and that would be y equals 3, but we just learned that we could cheat that as y equals 0x plus 3. Okay, and that graphs as a horizontal line. So a zero slope is always a horizontal line, always. And lastly, we can have undefined, or mom has you right, does not exist, okay? And that's when you have x equals 3. Okay, that would be a vertical line. Like that. Am I in the glare? Ah, I missed it. Cool. Okay, so those are the three things whenever you're doing a line, graphing a line, not doing lines, that's kind of not good to do, but whenever we're graphing lines, okay, or talking about slope, there's 4 types. Either you're going to have a positive slope, it always looks slanted in this direction. A negative slope, a horizontal slope, which is 0 slope, or a vertical. Okay, vertical, I'll put that there. Now, that's implicit in some of mom's homework, but I wanted to make sure everybody picked that stuff out. All right, I need to erase that. Any questions about it? That's just something you should know. It's a nice thing. Is your life going to be over if you don't know this stuff? No. Is your life going to be a little bit simpler in math if you do know this? Yes. Okay, so this isn't critical, but it's nice to know. Any questions about positive, negative, 0, or undefined slopes? All right. I want to erase the whole board, get going new stuff, but we've got enough people here tonight. Most of us are here. This Thursday, we will be at Mesa. This is going to be our first face-to-face meeting at Mesa. I know I sent you guys emails. Okay. We'll be in room MS 120. Okay. You have to have a mask. Okay. Not a face shield. It has to be a mask. Okay. Face shields don't count. There's a bunch of them out there. Okay. Yay me. Okay. This is my mask. I even have an N95, and I can talk through any mask in the world. So you'll be able to hear me quite well in the classroom. Here it might be a little muffled, but in the classroom you'll hear me. You got to have this kind of mask. Okay, a regular old, doctor's mask, N95, whatever you want. Like I said, there's a bunch of them around campus. Grab 1 or 2 when you come in. But you do have to have a mask. It has to stay on the whole time we're in the classroom. One of the things that I will, it doesn't even matter. It's not because of the COVID crud. Look, I know sitting in those chairs for a couple hours is a pain, a real pain in the real rear. Okay. If you want to get up and go outside, my feelings are never hurt. Okay. So if I'm talking, you're going, I can't take this anymore. I got to go outside and stretch. Just get up and go outside. It's okay. I'm not going to get hurt. That's okay. Okay. If you want to go outside, just take your mask off so you can breathe, a little bit like that. Fine. That's cool. Then just come on back in when you're ready. Bring paper. Okay. When I give tests and quizzes, well, first off, you need paper to take notes on, duh, okay? But when I give tests and quizzes, I have students usually use their own paper. So do bring paper, do bring pencils and pens, do bring your calculator, okay, and all that stuff, but paper for sure, okay? There is some confusion about, can you eat and drink in class? The technical answer is no, and then they back off of that, okay? If you slip your mask down so you can take a little drink, cool. If you have a straw that you put in your drink so you sip it, okay, that's even better because then you're not taking your mask down. If you have to eat, go outside. Okay, that's the only thing that I've been told is, no, we don't encourage eating, okay, but if you have to eat, go sit outside. Okay, we're on the first floor. And there's a little garden area out there, patio, well, garden. If you think rocks make a garden, great. But there's a little garden area out there. You can go sit and you can eat, just munch on something, and then come back inside. I will try to take a break every hour. I'll do that for 5 minutes. Okay. Here's the only bad thing. We're going to be in the classroom. I can't tape. I can't record anything. So Thursdays will not be recorded. So if you miss a Thursday, you might want to make sure you make friends with somebody in the class, or Lisi might take good notes and then be able to put them up or give you her notes or something like that. Lisi is our tutor. I'll talk more about her tomorrow. Okay. But I can't videotape anything. So those of you who miss class and rely on the videotapes, Thursdays are going to be kind of screwed. Sorry. All right. I want to erase the board. Anybody got any questions either about slopes or what's happening on Thursday? All right. Then the next big topic that I'm concerned with is how to graph a line. This is still part of review. Okay. There are two methods. Neither one is better than the other. Neither method is better than the other. I know that you've had instructors in the past, mostly probably from high school or junior high or something like that, who said, no, you have to do it this way. Oh, that's a bunch of bull. Okay. Remember, I taught high school for 33 years. I don't care. But the two methods. Suppose you have this equation. Okay. Then in my mind, the best way to graph this, okay, is with a table of values. And the easiest one is to use the intercepts. Okay, so we talked last week, an intercept means if X is 0, that's a Y. Come on, why wasn't somebody yelling at me? 2X was 3Y. If X is 0, then this drops out of the problem for a second. 2 times 0 is 0, it's gone. 3Y equals -12, Y is -4. That gives us the ordered pair 0, -4. And then pick the other one. What if Y is 0? If Y is 0, the Y drops out, so we get 2X is -12, X is -6, so we get the ordered pair -6, 0. Okay, if I wasn't talking, we would have been done by now. Okay, somewhere back here is -6. So my line looks something like that. Okay, something like that. Okay, real fast. Some of you don't even need a table. You can say, if X is 0, Y is -4, and you just go right to there on your graph. You can do the table bit in your head. Great. If Y is 0, X is -6. -6, 0. You can go right to there. That's cool. If you can do that, that's fine. The alternate way to graph is if we have this -4/3 X minus 2. Okay. This was called, remember, slope intercept. Okay, now this is going to be a little bit tricky because I kind of covered this last week real quick right before the quiz. So from this, we get two bits of information. First, we get our slope was -4/3. Okay, that's the slope. And then we get that the y-intercept is the ordered pair 0, -2. Now, I've gone over that a couple times. Is that okay with everybody? By looking at that, I got those two pieces of information instantaneously.
No.
Okay, what don't you like?
Would you don't mind to guide me to get those values?
Okay, because I am comparing this against this formula. That was called slope-intercept formula. And the M is the slope always, and the B number is the y-intercept. So for example, if you had y equals 5/7 x minus 52 or something crazy like that, here's your slope, here's your y-intercept. So we would say the slope is 5/7. The y-intercept is 0, negative 52. Does that help or not?
Yes.
Okay, it's just a matter of memorizing this formula. This was called slope-intercept formula, and it tells us information without having to do too much work.
Thank you.
Sure. Anybody else? Anybody? Bueller? Okay, so now to graph this gets a little bit weird. Okay. We always start at 0, -2. We always start at the y-intercept. That's easy. That's our starting point. But the confusion comes, what do we do with a negative slope? Now, earlier, I told us that all negative slopes are slanted this way. Okay, but let's make sure that that happens. So one of the things we've talked about here is slope is -4/3. And we've said slope is represented by the cute little phrase, rise over run. Okay, rise over run. So what this literally says is from the y-intercept, you're going to rise -4. Okay, well, that actually means you're going to go down 4, 1, 2, 3, 4. Okay, and you're going to run +3, 1, 2, 3. Okay, there's my line. Or just to confuse the issue, we talked right at the tail end of class that as a mathematician, you can move the negative sign in a fraction from numerator to denominator at whim. Hey, I don't like it on top. I want to put it on bottom. Oh, I don't like it on bottom. I want to put it on top. Cool. Okay, it doesn't matter. You're going to get the right answer. But check out what's going to happen. This says, I don't know if this color is going to show up. This says from our start, okay, we're going to rise 4. So we're going to go up 4. 1, 2, 3, 4. And we're going to run backwards 3. 1, 2, 3. Notice we get a different point. I don't know, does the blue show up at all to you guys? Or does it just look like icky black? Okay. We got a different point, but notice it creates the same line. Okay. So it doesn't matter where you put that negative sign. Put it on top, but apply the rise over run rule correctly, or put it on bottom. Put the negative sign on bottom and apply the rise over run rule. You're going to get different points, but the same graph, the same line. Because remember, a line is made up of an infinite number of points. And we just need 2 of them to graph. Now I want to do one more thing with this problem and then move on to brand new stuff. We doing okay on that? Anybody have any questions? I want to do one more thing with this. But does anybody have any questions before I go off and do my one more thing?
Professor, do
No.
you know if mom's going to have an issue if the numerator or the denominator has a negative sign, or does she already know that?
She has not, as far as I know, no, there hasn't been an issue. Okay, traditionally we like it in the numerator, but I do know that some of the problems she's given you go off. Like if you use rise over run, you're going to go off the screen. Okay, so you've got to flop the negative sign to the bottom so you can use rise over run to stay on her grid. Does that make sense?
Yeah, no, I've run into that problem, so that answers that.
Okay, cool. Okay. Lisi, for your information, mom is short for the homework software that the class is using. It stands for My Open Math, and I'll get it to you, but mom stands for the homework software. And it's easier to call it mom than it is to call it My Open Math. And then you can yell and talk about your issues with your mom. And okay. There will be an occasional question. Can you find this ordered pair? If you used the slope was -4/3, you went from here to here using -4/3. Can everybody find this ordered pair? Okay, and if we use the slope 4/-3, if we use that one, can everybody find that ordered pair? Let's take a minute or two for you, like a minute. All right, let's see what happens here. So if we start at 0, -2, but let's use this slope. This says we rise -4. Well, rising changes the y value. Okay, we run 3. 3 changes the x value. Rise and wise, they rhyme. When you rise, you either go up or down, you're changing the y value. When you run, you're going sideways, you're changing the x value. So my new point will be 3, -6. So this point right here is 3, -6. And some of mom's questions will ask you to identify that new point. Not just plot the new point, but tell me the coordinates of the new point. Or at least, at the very least, you have to know it. Now, if we start at the same point, 0, -2, but we use this slope. Okay, so we rise 4. Okay, so we rise 4. We run -3. So this point is -3, 2. -3, 2. Okay, again, it all depends on what mom asked you, what the graph looked like. You might be asked to find these 2 points. Not always, but every once in a while you might be asked to do that. This is how I think of it. I actually do most of the work in my head. Okay, when I do this, I do know the top value is changes the y value, the bottom of the slope changes the x, and that's it. Okay, or not okay?
Okay.
Okay, with everybody. All right, here we go. Now, this is chapter 4.6. And we want to I'm going to say determine the equation of a line. That's going to be the topic. Determine the equation of a line. Now, there's a lot of words that mean the same as determine. We could say find the equation of a line. We could say write the equation of a line. We could say calculate the equation of a line. They all kind of mean the same thing. Okay, so mom is not going to be consistent. And when you move to other math courses, no teacher is going to be exactly the same. But whatever it is they're saying, hey, I want the equation of this line. All right, here's a key. I must give you the slope and a point. Okay, that's critical that you understand that. If I ask this question, determine the equation of the line, then I have to give you this information. However, I and every other math instructor in the world reserve the right to hide some of this information from you. It has to be there. It has to be there, but it also might be hidden. So I want to walk you through a few basic equations, a few basic problems. Okay. This technique that I'm going to show you is the one that's preferred by most instructors and most students. It is absolutely not the one I prefer. There's a better one, but it requires more memorization. There's a better, faster one, but it needs more memorization on your part. So students tend to go, no, I can't memorize anymore. So they go, no, don't want to learn the new way. Okay, but there are better, faster ways if you can memorize one new formula. But I will do that after class if somebody wants me to show that. I will not show that in class. I'll stick with one technique. All right. Okay, so we're going to take an example. Find the equation of line with slope, I don't know, -3/4 and passing through the point. I don't know. I'm just making this up. 7, -2. I'm just making up this problem. Find the equation of the line with the slope -3/4 and going through the point 7, -2. So I've given you all of the information you need. Okay, now here's how we go. The first thing we do is we start with this formula. Okay, that's the first thing we do. We plug in, second thing we're going to do is we're going to plug in everything we know. For example, -2 equals -3/4 times 7 plus b. Okay, so notice when I give you the point here, this is the x, this is the y, this is the m. So all I did was take this information, x, y, and m, and I plugged it into the formula for x, y, and m. Okay, now at this point, third step is we're going to solve. Why can't I write? Solve for b. That means get B alone. Do whatever arithmetic it takes to get B alone. Now, this particular problem that I just made up has really some ugly fractions. Not impossible, but ugly fractions. So we've talked, and I'll help at the end of class, those of you who don't remember how to use your calculator, the fraction button on your calculator. But I'll solve for B, okay? Couple ways of doing it, but I'm gonna go, since you have, I'm gonna assume you have a calculator. So first thing I'm gonna do is -3/4 times 7. Remember to multiply fractions. You multiply top times top, bottom times bottom. Okay, so 3 times 7 is 21 negative, 4 times 1 is 4. Then I want to get B alone, so I'm going to add 21/4 here. Okay, that's going to give me B all by its lonesome, B. Now this is where you could probably do that step in your head. You could probably multiply those in your head. You could probably, on your paper, just say, I'm going to take away 21/4 from both sides. Where you're going to want your calculator is here. -2 plus 21/4. I believe it becomes 13/4. Can anybody confirm that?
Yes, that's correct.
That's correct? Okay. So fourth, we put it all together. We have y equals -3/4 x plus 13/4. That's it. We're done. That's the equation of the line that has -3/4 as its slope. It passes through that point, but we needed to write it in that format. That was it. So the solve for B, in my opinion, is the hard part because it occasionally uses fractions. -2 plus 21/4. Before we do another problem like that, does anybody have a question?
Yeah, where did you get that 13/4? I'm sorry.
Okay, well, first off, I use your calculator, but I'll show you what I did. I mean, if you're not sure, use your calculator just to add those, -2 plus 21/4 on your calculator. And that would look something like -2, remember you got to use that, plus, and remember on your calculator, you have this button. Okay. Do you have a TI 36 or 35X or whatever this is, 36X? If you do, then it'll have this key. If you don't, okay, it'll have a different way of doing it. But if you do that, it'll show you as 13/4, or it'll show you 3 3/4, whatever.
Yes, I got it. Thank you.
Okay, but let me show you what I did, guys. Let me show you, okay, because I'm old, okay, and I've been forced, because remember, when I was in school, okay, we had just invented fire and the wheel. So, okay, we didn't have calculators, we didn't have anything. We had to learn to deal with fractions. If I got a common denominator, do you remember those? Okay, you can take -2 and make it into a common, and make it so it has a denominator of 4. Okay, -4 times -2 is -8. So -8/4 is the same as -2, but it has a common denominator. Now, when you add fractions, you're supposed to add the numerators. Well, this is actually subtract because one's positive and one's negative. So that's how I got 13. Keep the denominator. So just get a common denominator. Okay, that's technically what I did. All right, let's give you guys one. Do you have this one copied down? I'm going to have to erase this work at least. Anybody still copying down this problem? Okay, here we go. New problem. Example, I want you to find the equation of a line. Okay, that has a slope. Somebody give me your favorite slope.
1/2.
Oh, God, okay. 1/2 and goes through the point. Come on. Somebody give me your favorite point. If you guys
Zero
are
comma
not,
six.
-4.
how much? 0,4 too easy. Maybe not. Okay, 0,4. Okay. So find the equation of a line. That actually will be a good question. Oh, crap. That was stupid. Okay, for all of you who have to view this recording, I apologize. This problem over here, I forgot to turn the recording on. Sorry. But we're doing this problem here. Find the equation of a line through those 2 points. The first thing we had to do is calculate the slope because it was hidden. Yay for that. I got 20 over -8, but, okay, always reduce, okay? And personally, I'm going to cheat the negative sign to the numerator because traditionally that's where we want it. Doesn't make any difference. It just kind of makes my problem easier to do in my mind. Okay, so we move over, we start with y equals mx plus b. Oh, which point do I use? Oh, they're both got negatives. I don't know. For lack of anything better, I'm going to use this one. I don't know why. I just am. So I plug everybody in. I get -8 equals -5/2 times 3 plus b. So -8 equals -15/2 plus b. 3 times 5, 15. Add 15/2. Okay, use my calculator. I'm going to use my calculator. In my head, I get -1/16 equals b. Well, that scares me. Better double check it. So I have
That's
-8.
something different for that.
Really? Okay.
Wouldn't
Plus.
it be -1/2?
Well, wouldn't what be?
Wouldn't b be -1/2?
Oh yeah.
Yeah, also
What
got that.
what a dip. I'm yeah, keep the denominator, idiot. Okay. Yeah, you're right. Oh, wait a minute. Let me do this. Let me just double check it. 15/2. Yes. What a dip. Where did I come up with the 16? I don't know. Okay. I have no idea. Okay. So the moral of the story is don't do it in your head. Use your calculator. So here we go with B was that. So put it all together. Final answer, y equals -5/2 x minus 1/2. Okay, thank you. You saved me again. Okay, let's take about a 3-minute break. Stand up, stretch. I need to erase the board. We've got like one major topic and a tiny little topic to go tonight. Any questions on these two examples? The one I stupidly did not record and this one here? No questions? Okay. I haven't, well, when we're discussing lines, two lines, okay, there are three possibilities. Either they just cross, or they're parallel to each other. Okay, remember, parallel lines never cross each other, or they cross and are perpendicular. And perpendicular means they form a right angle, which is 90 degrees. So, we're going to come back next chapter and discuss this in more detail. But when lines cross, okay, if they cross, then that's kind of boring, okay, for us right now. But if they're parallel, then something neat happens. It means their slopes are equal, or the slopes are the same. If two lines are parallel, look at those two slopes. If two lines are parallel, their slopes are the same. They both have the same slope somehow. So one of the things mom is going to give you in the homework, okay, is she's going to take about line 1 and she could talk about line number 2. Here's line number 1 and line number 2. Duh. And if line number 1 has a slope of 3/4, okay, and I say they're parallel, then line number 2 must also have a slope of 3/4, because parallel lines have the same slope, always. Perpendicular lines are kind of wacko. Perpendicular lines, if you look at them, okay, here's one line, here's line 1. Perpendicular lines, when they cross at right angles, that's what perpendicular means. They cross at right angles. Then their slopes have a very, very special relationship. Their slopes are the opposite reciprocal of each other. Okay, slopes are opposite reciprocal. Well, let me show you here, over here on that, on this problem here. Suppose I told you this line was 3/4 again. The slope of this line was 3/4. Then the question is, what's the opposite reciprocal? It's got two things that are changing. Well, this is line number 2, whoops, line 2, okay, then its slope would be the opposite. If this is negative, if this is positive, this is negative. And reciprocal means to flip it over into 4/3. The slopes are the opposite reciprocals of each other. If this was 3/4, this is its opposite reciprocal. Okay. What if New problem. Okay, what if I gave you this line here, you can call this line 1, and I told you its slope is negative 5/3. Okay, so here's a line, and I'm just making this number up. I'm not trying to be fancy about it, but it's crossed by a perpendicular line somewhere. It's crossed by a perpendicular line. There's line 2. Then the question is, what is the slope of this line? Okay, it's got to be the opposite reciprocal. Two things have to change. So this line, the slope, would be the opposite. If this is negative, this is positive, and the reciprocal is 3/5. So we're going to take advantage of those two concepts to do some more finding the equation of a line stuff. Okay. Parallel means the two slopes are the same. Perpendicular means the two slopes are opposite reciprocals of each other. Okay, before I actually do some problems, anybody need any clarification on parallel lines or perpendicular lines? There's a whole slew of other lines that just cross and they have nothing special about them. They just cross. They're stupid. They just cross. Okay. But if they cross at right angles, at 90-degree angles, then their slopes have a special relationship. Any questions about parallel lines, perpendicular lines? Mom has a whole slew of questions about, are these lines parallel or are they perpendicular? All you have to do is look at the slopes. Are they parallel or perpendicular? A little bit more difficult than that, but I'll let you guys yell at me. Okay, so suppose I said find the equation of a line that goes through the point 4,7 and is parallel to the line y equals 3/5 x minus 27. Okay, find the equation of the line that goes through this point 4,7 and is parallel to the line y equals 3/5 x minus 27. Okay, when I started this section, this is still chapter 4.6. I had to do a slight detour to talk about parallel and perpendicular lines, but I brought it back to this. Find the equation of line. Okay, I told you needed, I have to give you two things. I have to give you a point. I have to give you a slope. I have to. There's no getting around it. But I said I reserve the right to hide this information. So in this problem, I have a point. My point is 4,7. That's pretty clear. Do I have a slope for this problem?
Yep.
Yes,
What is it?
3/5.
Yep, it's 3/5 because I'm looking at the slope intercept form. right there. There's my slope. Okay. So it was hidden from you, but within the work. All right, I'm going to pause. I want you to finish it off, find the equation of the line. Okay, so while the recorder was off, I went and did this. We figured out that the slope was 3/5 because parallel lines use the same slope or have the same slope. I wrote my formula, plugged in the point and the slope, solved for B. I got B is 23/5, and I checked it on my calculator. And so there's my equation. This equation, okay, goes through this point and is going to be parallel to this line. And I'm done with that problem. Questions about that problem?
What happened to the -27?
Okay, what does slope care about the y-intercept? Nope. The y-intercept doesn't affect the slope at all. It just says the slope was 3/5. That's it. Let's look at it another way. Three-fifths. Okay. This could be y equals 3/5. I'll get out of the way, x plus 1. The slope is 3/5. This is 1. This could be y equals 3/5 x plus 10. Again, the slopes are 3/5, okay, because the slopes are the same. The y-intercepts are different, but they're still parallel to each other. This one down here, this could be y equals 3/5 x minus 27, because its y-intercept is -27. All parallel means is look at the slope. That's all it means. It means nothing about the y-intercept, but all of these are all parallel to each other because they all have the 3/5 x. I'm not sure that was a good answer. Are you okay with that or not?
That's fine.
Okay. It was meant there to scare you. It was meant to go, oh my God, what am I going to do with that? And apparently I got you. Anybody else? Okay, then last of these problems, then we move on to the last topic of the evening. And actually, I think it'll be the last topic of chapter 4, which is pretty cool. Okay, so here we go. Find equation of the line through the point. Do I dare ask you guys? Do you have a favorite point? Okay. What? How much?
4/6.
Well, no, point 4,3.
Yeah,
Oh.
4,6.
6. Okay. All right. Okay. And is perpendicular to y equals -4/3 x plus 19. Find the equation of a line that goes through the point 4, -6 and is perpendicular to y equals -4/3 x plus 19. Okay, so once again, I have a point which is 4 comma negative 6. My slope is a little bit harder this time. Because it said perpendicular, okay, because it said perpendicular, I have to use that opposite reciprocal. So you'll see people write something like this. M equals negative 4/3. And an upside down T is our math symbol. You don't have to use it. Don't panic. Okay. Is our symbol for perpendicular would be positive 3/4. You might see someone write that just in their notes. The slope of the original line was negative 4/3. But the perpendicular slope, that's the symbol for perpendicular in math. Again, you're not going to be held accountable for that at all. Don't panic. The perpendicular slope is the opposite reciprocal of the original slope. So I have that. Well, so that's my point. That was my hidden slope. Okay, let's pause it, finish this one off, and jump to the last. Okay, so of all the problems, okay, I got a nice B value with -9. So I plugged everybody in here. 3/4 times 4 was 3. Eventually, again, reduce your fractions. 3/4 times 3 is 12/4, which reduces to 3. Take away 3 from both sides. That was the answer I got. Again, I'm kind of speeding through my steps in my work. I'll be happy to slow down and explain it to you guys. Any questions on this? Chapter 4.6. You should now be, after you've done some work on mom, okay, experts in determining the equation of a line, finding the equation of a line. Okay, any questions on either of these two examples? Because I want to move to our last topic of the night. And we still might get out of here by about 8:30 or 35. Yay! Did NFL football start? Oh, that was last night. No, it didn't start. Yeah, we're all going to miss it this coming Thursday, aren't we? Bummer. Okay. I am recording. Okay, we're on chapter 4.7. I guess it's kind of weird when this big face comes right down to the screen. Figure out if we're recording. We're going to graph what's called a linear inequality. It's pretty easy, okay? Let me give you an example of what your answer might look like. First off, you're going to graph a line, and then you're going to shade on one side of the line or the other. That's what your answer is going to look like. Okay, you're going to graph a line. Now we need some discussion about that line, and then some further discussion about where we shade. How do we know where to shade? This line is technically called a boundary line. Okay, it cuts the plane of the whiteboard or the chalkboard into two halves. Okay, it's the boundary between the shaded part and the unshaded part. However, it's a little bit tricky. If you use a less than or a greater than, then your line should be dashed. Okay, meaning dotted. Your boundary line is a dotted line. But if it's a less than or equal or greater than or equal, then your line should be solid. And that always confuses the heck out of students. Okay, so we're going to draw a line here. And we have to determine when I draw that line, is it a dashed line or a solid line? That's number one. Number two, I have to determine, do I shade? On what side of the line do I shade? And there's trick ways and there's regular ways and all kinds of stuff. So let's just do it and see how we can come over this. All right, real simple. Y less than 2/3 x plus 4. Okay, what you're going to do is you're going to think y equals 2/3 x plus 4. You're going to think that. And you're going to graph that any way you can. Now, we've talked about it a couple times now. Do I want to build a table of values, an XY table? You can. Okay. Do I just want to use slope intercept? You can do that also. That's totally up to you how you're going to graph this line. Okay, y equals mx plus b. Probably this one, the y equals mx plus b would be better, because we can look and say, look, our slope is 2/3, okay, and our b value is 0,4. Okay, just by glancing at the equation. But you have always the two options. Which is the better option for you, to build a table or to use slope intercept? That's strictly a personal choice. All right, I'm going to use this. So here I go. Okay, so my b value is 0,4. Sort of like there's 4. I'm going to use rise over run. So I'm going to go up 2, over 3, get a new point. Mom may ask you for that. Oops, I've already screwed up. Can somebody tell me how I already screwed up?
Should be a dashed line.
Yes, you're 100% right. You guys pick up on that? Less than, okay, means it should be dashed or dotted or whatever you want to call it. So, but that's easy up here on my whiteboard. I can just kind of fake it. It's dashed now. Okay. Secondly, we have to determine where to shade. Now, there's a shortcut and then there's a right way of doing it. And both of these are necessary for you guys to learn. If your original problem was in slope intercept form, there's my original problem. It is in slope intercept form. Then the inequality is trying to tell me where to shade. Less than. Less than. Well, relative to this line, where is less than? Anybody?
The bottom.
Bottom, below. Less than would be below this line. So, but wait a minute. I'm not sure you guys heard me, okay? Because I put a lot of ifs in there. If your original problem was in slope intercept form, It was. Then your inequality symbol is telling you where to shade. Less than kind of means below. So all you have to do is shade this direction and you're done. That's it. That's your answer. So you graph the line, remember to dash it. Okay, and then you have to figure out where to shade. Okay, now I want to make it more complicated. Duh, I have to do that. I mean, you know, I got to kill time here. We can't possibly go home at 8:25. The correct way to figure out where to shade is to use what's called a test point. Now, I'll be really honest with you. Did you need this correct way for this problem? No, because the shortcut worked perfectly. But I want to show you the test point because my next example will require the test point. Okay, so the test point says pick any point you want that's not on the line itself. So you got 1 billion points over here you can pick, or 1 billion points over here you could pick. Okay. I suggest that you pick the lazy point of 0, 0. Remember, you're a mathematician. You're inherently lazy. That's why we have all these rules. Okay, so you don't have to do as much work. Oh, if it's this, I do this, I'm done. Okay. All I said was your test point has to be a point that is not on the line. Now, you could have picked anything. You could have picked 5, 0. You could have picked -7, -16. That would be way like down here. You could have picked any of those. And they'll all give us eventually the correct answer. But remember, we're trying to be lazy, so we want to pick the easiest point, 0, 0, if we can. And you plug it into the original. So we'd have 0 is less than 2/3 times 0 plus 4. So that translates, or that simplifies to 0 is less than 4. So check this out. That is true. My test point was true. It was below the line and true. That implies any point I would have picked below the line would have been true. That's why I shaded it. Okay. If my test point is true, I shade towards truth from the line to truth. Okay. If for some strange reason my test point had been false. Okay, let's do another line. Da, 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 da. Let's say I tested this here. My test point, for some reason, I don't know why, but it was false. Okay, here's my line. This is false. Where's truth? If my test point was false, where is truth?
On the top.
Above it. So you can't go wrong. If your test point is false, you shade away from false, always toward truth. Okay, so I'm going to do one more example, then we're done for the night. But the idea was to graph a linear inequality, you first just simply graph the line. Okay, that's all you do, just what we've been talking about. But you have to remember, do I use a dashed line or a solid line? That's number one. Okay, now you have to figure out, where do I shade? If your original problem was less than, it was slope intercept form, then the original symbol, the less than, is telling you where to shade. Less than means below. If that had been a greater than means above. It's that simple. If you're not sure, we pick a test point. So let's do one more problem. Okay. So I want to graph x minus 3y is less than or equal to 12. So let's see how far you can get. X minus 3y is less than or equal to 12. Okay. When I started this, I keep reinforcing to you guys, you don't always have to use slope intercept form. If the problem uses slope intercept form, great, use it. But if it lends itself to using a table, then use that also. Don't get stuck on having to I can only do it this way. Okay, I feel like a Rain Man. Okay, you can't, you've got to be flexible here, guys. Okay, all right. I personally, and I want to do this for a couple of reasons, I think a table is really good to use. And I think the intercepts are really good. If X is 0, then plug it in. Oh, hang on. Let's do this. We're thinking. We have to think this. X minus 3y, okay, equals 12. That's kind of what we're thinking. Strip away all the BS. That's all we're doing. Okay. Build a table of values, X, Y. Okay. If X is 0, then this part of the problem drops out because that's 0. That solves Y is -4. Okay. If Y is 0, okay, then the middle part drops out and X is 12. Okay. Think about how fast this would be if I actually wasn't talking. So if we go 0, -4, sort of like that, I'll get out of the way in a minute. Negative and 12, 0 is somewhere out here like this. Somewhere like that. So 0, -4 is there. Okay, 12, 0 is out there somewhere. Obviously not drawn to scale. So I'm going to draw a line. Am I going to draw a solid line or a dashed line?
Solid.
Solid, because of the less than equal. Okay. Okay. Now I have to figure out where to shade. I picked this problem to show you the test point. I did this on purpose. I know some of you graph this a different way, but I want to show you the test point. I have to figure out where to shade. Okay, and so I am going to test my lazy point 0, 0. There's my test point up here. All I said about the test point was pick a point that's not on the line itself, that boundary line, and plug it into the original. So the question is where's the glare? I'm right in the middle of the glare. 0 minus 3 times 0 is less than or equal to 12. Well, that becomes 0 is less than or equal to 12. If I simplify my arithmetic, so that's true. Again, my test point was true. So that means truth is above the line. I always shade towards truth. So I will shade this direction and I'm done. Okay, that's it. That's all you have to do. That's all you have to do. All right. We'll talk more about this tomorrow. I am done for the night. Oh, one more thing. New grades are up online. I know only 2 people wrote me over the weekend about how to get your grades. So I assume you guys all understood that. But your newest grades, including your chapter 1 and chapter 2 homework that was due yesterday. Okay, those are all up online so you can see your newest grades. That's it. I am not taking roll tonight. Okay, see you all tomorrow. Bye.
Good night, Professor.
Good night.
Bye.
Thank you. Have a good night.